All right, welcome. This is the AP Physics Workbook Solutions. Here I'm covering Unit 3, Section 3.D, which is on vertical circles. So here's the scenario. A ball whose weight is 2 newtons is attached to the end of a cord of length 2m. As shown, the ball is squared in a vertical clockwise. The tension in the cord at the top of the circle is 7 newtons and the tension at the bottom is 15 newtons. Two students discuss the net force on the ball at the top of the circle. Okay? Here's Dominic and here's Carlos. Part A, cross out the incorrect statement for each student's argument. Okay? All right. First of all, Dominic says the net force on the ball at the top is 7 newtons since the net force is the same as tension. All right. So this makes no sense. All right. The net force of the ball is at 7 newtons. No, it says the tension in the cord at the top is 7 newtons. So that is wrong. Since the net force is the same thing as tension, no. That's not correct. Because there are more forces besides tension involved there. Okay? No. Carlos says no. The net force on the ball includes the centripetal tension weight. So the net force on the ball includes centripetal force. That's not correct. It includes the tension, that is correct, and the weight, correct. The tension and the weight are acting downwards and has to be added. That is correct because they're in the same direction. Then you need to figure out the centripetal acceleration, which includes the net force. That is wrong. Okay. Here. All right. So what the mistakes Dominic and Carlos didn't understand is these notes, okay? So these notes should explain to you how I got these answers. First of all, centripetal force is not a new force, okay? Centripetal force stands for any force that keeps an object following in a circular path. Okay, so think about this as just F net, or the summation of all the forces. In our class, centrifugal force is a combination, look at it, it's a combination of certain things. The gravitational force, which is mg, the normal force, which is just N, which is always perpendicular to the surface, tension, which is T, and sometimes the static frictional force. These are all the forces that make up the summation of the forces in a circle, which we called it the centripetal force. Okay, there is no such thing as just the centripetal force. Centripetal force, again, is a summation or a combination of all these forces. Okay, so using the notes for centripetal force, you can now write down in a few sentences here what is wrong. Okay, so I would say Carlos is correct that the net force is a combination. Okay. The correct combination of the forces are the tension and the weights. Okay. Or the force done by gravity. All right. Now, at the top of the circle, the two forces act are the two forces are in the same direction, so we add them together. Okay, the centripetal force is the combination, exactly like what the note says, is a combination. In this case of the in this case is a combination. In this case It is the gravitational force and tension force. Okay, so there you go. All right. And here again are your notes for that. Good. Okay. Next, um, using this diagram, show the circular path of the ball. The dots represents the locations. Draw the free body diagram, labeling the forces exerted on the ball at each point. Draw the relative length of all vectors. So make sure the lengths are correct. Okay. All right. So what I have here are some notes. This is how it looks like clockwise, counterclockwise. Okay. You see the velocity is all tangent. The acceleration is pointing towards the center. So F net, or the centripetal force, is going inwards. Here, same thing, but clockwise. All right? Good? All right. And this is uniform motion too. Okay? All right. So let's draw it here. Where is Q? Q is seems on the bottom, and it seems like this object is going what? Circle is going clockwise. Just want to make sure you understand this is going clockwise, okay? All right. So here, I made that purple, okay? All right. So here, um, for G, okay, for G, they want us to draw the free body diagram and label the forces. Please understand this is labeling the forces, all right? So I don't need to label the velocities, label the forces. So it doesn't care about the velocities, okay? So let's just make that orange, okay? So what are the forces on that make up Q, okay? And again, here's the string, right? So if the string is down here, how is the force acting? Okay, the string is pointing upwards towards the center, right? Okay, and what about P? Again, it is pointing towards the center, right? Um, Z pointing towards the center, and M pointing towards the center. Okay, this is where all FT is. FT, 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 and FT. Okay, here you go. Oh, sorry, that's not pretty. I try to do it as best as I can. That's FT. That's FT. And F. Oh, sorry, that's ugly. FT. All right. So these are all where the force centrifugal is pointing. Good. All right. So you see how force the force of tension is determined by where the string is. Next, what about the force on gravity? The force of gravity is always pointing what? Towards the center of the earth. And in this case, it is right pointing down. And again, it's smaller. FG, down, FG, down, FG, and down, FG. All right, so here, now if you're wondering from part A, why do you add them, right? At the, what is this? Sorry, did this correct? At the top of, so at the top of the circle, do you see this at Z? At top of the circle, the force of gravity and the force tension is going down. They're in the same direction. That's why here in part B, I told you to add. Okay? This should explain to you why. Good? All right. Remember, force of gravity always goes down. Force of tension depends on the string's location. Okay, part D, right? You're going to derive the expression for the minimum speed the ball can have at point Z, right, which is up here. Okay, this is on top without leaving the circular path. For each line in the deviation, explain what mathematically happened. Okay, so this is what you have. In the formula sheet, you might have also seen this version of it. Okay. You might actually seen this version of it. Um, AC is equal to summation F is equal to M. Okay, good. Okay, so uh, we are going to actually start from the top one. Okay. Again, you can start here because you are given that on this is on your formula sheet. So this is on your formula sheet. This is on the formula sheet. Okay. Sheet. Okay. Then you could multiply m to both sides to get this equation. Okay. All right. So now you want to ask yourself, what are the two forces right here? And this is what? Uh, this is ball with at z, so it's on top. Okay. All right. Okay. Okay. Now we have to ask ourselves, what are the forces that make this up? And we know that it is what at point z. It's right here. Okay. I can just grab it for you if you would like to see. We had the two forces, which is just right here. It is going to be F T plus Fg is going to be equal to, right here, you have MAC. Okay, what I wrote here is you just label the forces. All right, now we could also make a substitution here. Ft plus Fg is equal to M V squared equals to R. Here I let AC be equal to V squared over R. And again, you're allowed to do this because this is in the formula sheet. Okay, you're allowed to make that substitution because again, it comes from the formula sheet. Good. Next, we see that the tension force is at its minimum speed, because it says here minimum speed. So at minimum speed, okay, Ft goes to 0. So this becomes 0, and you only have mg left, equals to mv squared over r. Good. So you have mg is equal to mv squared over r. So the m's cancel out, cancel out, cancel out. You have g is equals to v squared over r. Okay. Then you want to solve for velocity. So get v alone by doing some algebra. So you're going to multiply by r, gr. You want to see it? Here, that's what I mean. Multiply by r, multiply by r. Okay. Get you here v squared. Square root both sides. Okay, so this cancels out. You get you v equals to gr. Okay, so this is the velocity. So this is the minimum speed the ball can have without leaving the minimum. This is the minimum speed the ball can have at point Z. Okay, and point Z is referred to as down here as of the rope. Okay. Right. Okay, good. All right, give me 1 second. If you would like to see how this problem is done mathematically, I have a problem given to you right here. All right. Here you go. So here it gives you the mass of the ball, and it gives you the radius of the ball, and it's swung in a circular motion. Part A, which is this part, the first top part, it asks you to determine the minimum speed of the ball must have at the top of the arc so that the ball continues to move. Okay, and it says minimum speed the ball must have, so the ball continues moving. Okay, so here you go. They set up the same way. Here, they're just again they set up right here. This is Newton's second law. Here they label the forces, right? And here they say that for the equation we can use the tension force at point 1 would be greater than the V expected. We would ask for the minimum speed to keep the ball moving. The core will remain as long as the tension is in it. But if the tension disappears because V1 is too small, the cord goes limp. Okay, thus the minimum speed occurs when the tension force equals to 0. Okay, so this justifies the minimum speed at the top of the bar, right? Notice that the ft disappears. Same thing, divides over, and this is what you have. So the velocity here, and again, this is on top, right? This is on top of the, on top, okay? Here you go, right? The formula is done the same exact way, right? But this time, for part B, it is the calculate the tension, right? And this is how you would do if you want like to get the tension force, okay? But here is an example problem of what you can try, okay? But it's done the same exact way, right? Next point, part E, okay? Suppose that the string breaks at part D. And so I have the example here for you because part D is when it's on the where's part D? Part D is when it's on part P. I mean, part P is when it's on the side. Yeah, it's on the left side. So that's why I have it on the left side here. Okay. Suppose the string breaks. Describe the motion of the ball after the string breaks. Okay. Here's some notes for you. Um, When you are swirling a tennis ball on a string around in a circle, when the string suddenly snaps, what direction does the tennis ball fly? And this is from the top view, okay? The answer would it be 1, with the circle, 2, tangential to the circle, 3, outwards, 4, curving outwards, or 5, perpendicular outwards? The answer would be 2. Why? Because there are 3 reasons. 1, the instantaneous velocity at any point is tangent to the circle. So this is tangent to the circle. 2, the string snaps, so there's no force acting on it. And 3, based on Newton's first law, the puck or the object will move at a constant speed on a straight line. Okay, using this idea, you can write this. Okay, so here it is a ball and the string breaks. So what is the position? Okay, the ball will travel straight forward up. Okay? Tell the motion of the ball from the time the string breaks until it reaches the ground, right? Goes straight up, then straight up, then right. Once it goes up forward, it becomes like a projectile motion. So the object is the ball will travel straight up. The ball will then reach its maximum height, then fall down to the ground. To the ground. Good. What about its velocity? Well, you can say that the speed of the ball decreases until it reaches the maximum height. Okay, so it has a when the string snaps, the ball will travel with a velocity. The velocity the velocity will go to 0 as it reaches its maximum height. And again, it reaches its maximum height because the velocity goes to 0. Then the velocity is negative as the ball travels down to the ground. Again, this is the behavior of a projectile motion. Positive velocity going up, reaches the maximum height, goes down, negative velocity. And acceleration, right? We know that there is no thrust, okay? There is no thrust, like there's no engine, right? There's no thrust, so the only acceleration in the vertical direction is due to the force of gravity, which is 9.8 meters per second squared downwards. Force due to the earth, gravity, you could say the force of gravity, or you could say the force acting on the earth on the ball. Earth on the ball. Okay, this would be a more complete answer of acting force of the acting on is due to the force is to do of the force of the earth acting on the ball. Okay, this would be a complete answer. You could write that, or you can change this by saying this is the force of gravity. Okay, because that is what gravity is. That's in a simple answer. Okay, all right, and there you go. Okay, again, here are your notes that explain part E. Here's part D. Here's the deviation. Here is it. Please understand that I made a little mistake here. So it is a minus when it's on the bottom, okay? But when you solve for it, it's still the same V, okay? But please be careful with your sign, okay? When it's on top, it's an addition, all right? Here you go. This is the free body diagram for around the circle. And this is just your basic vocab of centripetal force.